To show some of the aspects of reflection, we're going to use a fairly simple class, this one here called car. And this class has a couple of constructors. It has a default constructor and a constructor that takes an int. It has a method called drive, a method called accelerate, which is a private method, and a method called select drive, which is a private method. These are just two helper methods. So what can we do with reflection? Well, we know we can create instances. So I can say class CLS equals car.class, and then I can say cls.new instance, and I can create an instance of the car. And this is using reflection. We're creating the object using its type at runtime, rather than using the new keyword and discovering its type at compile time. And if I run this code, we'll see that an instance is created. There's no error here. If I go back into the car class, though, and remove the default constructor and run the code again, now we get an exception. We get an instantiation exception, which tells us that it can't find com.pluralsight.car brackets init. Init is the constructor. It's looking for a constructor with no parameters to try and call, and we don't have one currently. So let's put this back as it was. So that's about the simplest thing that we can do. However, once we have the class of the type we are trying to examine, we can discover a whole bunch of information about that class. So for example, we can say class.getMethods, and this returns an array of method types. And this gives me information about each of the methods on the class. So in here, for example, we could write a for loop. We could say for method in methods. And inside here, we can print out the name of the methods. We say %s/r/n, and then do method.getName. And if I run this code now, we'll see the name of the methods on the class. So notice in this list, we get methods from class itself and method from object. These are the methods that we derive from. So by calling getMethods, that returns a list of the public methods on the type and the methods of any types that we derive from. Notice as well, we get 3 wait methods. And that's 3 different overloads of the wait method. And we can see that by printing out the number of parameters for each method. So each method type has a function called getParameterCount. We can assign this to an int count, let's say. We can then do something like system.out and print out the count. Let's put this in brackets and say %d for the count. It's going to be an integer, and say count here. At the end of this, we'll do a print line, and we'll remove the new lines here. And then if we run the code again, we'll see that there's a version of wait with no parameters, there's a version of wait with 1 parameter, and there's a version of wait with 2 parameters. So getMethods returns all the public methods of the class and any classes or interfaces that we derive from or implement. We can also get the private methods of this class by using a similar method. And rather than calling getMethods, we can call getDeclaredMethods. So tidying this up slightly, if we say getDeclaredMethods here, and we'll put an empty line here just to separate the two. And if I run the code again, we get the list of methods here, and then following that we get the declared methods. And these include drive, as it was here, that's the public method with 2 parameters. But now we also get select drive, which is a single parameter, and accelerate. And that's a private method with 0 parameters. We can also, using the class, discover the classes that we derive from or the interfaces we implement. So in the code, I've created an empty vehicle class, and I've had our car class derived from this. So now inside main, we could say something like this. We can say class superclass equals cls.getSuperclass, and then say while superclass is not equal to null, print out the name of the class. We can print out, we'll do this as a print line, superclass.getName. And then finally say superclass equals superclass.getSuperclass. So we keep walking up the hierarchy. And then if we run this code, we'll see that the superclass of car is vehicle, the superclass of vehicle is object, and object has no superclass. So getSuperclass here returns null. Once we have the class object, we can then go ahead and discover which constructors the class has. We saw at the start of this module that trying to create an instance of the class, we'll try and use the default constructor. And we'll see in a moment there are ways of using other constructors within the class. So there's a constructor type, and we can get the list of constructors from the class by saying class.getConstructors. And the same as before, we can use getDeclared constructors, or we can use getConstructors to get the constructors from this object. So let's use getDeclared constructors to find our constructors. And then again, we can enter a for loop. So we can say for constructor C in CTORs. And initially, again, we'll just print out the name of the constructor, so c.getName. And if I run this code, we know that we have two constructors, so com.pluralsight.car and com.pluralsight.car. So just as with the methods, we'll use printf to print out the name of the constructor, and then from the constructor, we can call getParameterCount, and we can print that out. So we can do system.out.printf, %d, and print out the number of parameters here. And again, we'll put this in brackets, and again at the end, we'll put a semicolon, and then we'll print out a blank line. So again, if I run this, we'll see we have a car constructor with 0 parameters and a car constructor with a single parameter. So as well as getting the count of parameters, there's also a parameter type, and we can get the collection of parameters. So from the constructor, I can call getParameters, and that returns back the collection. And again, I can loop over this collection of parameters. We'll say for parameter p in parameters, and then each parameter we get, we can print out information about the parameter. So again, for example, we can print out the name of the parameter, and we can also print out the type of the parameter. So parameter.getType prints out the type information, and let's just comma separate these so we can do %s in both cases. So again, I can rerun the code. So we know this has no parameters, so nothing printed out there. This one, the parameter is called arg0. We don't get the full name, we just get arg0 here. So we know that in this case, it's an integer parameter, and we'll see a little later on that we can use that information to actually call the constructor and to create one of these objects. We can also get the parameters from methods. So here I've just brought the method code back in. We're calling getDeclaredMethods, and we're printing out the name of the method and the number of parameters. And if I just paste in the code from the constructor, we can change this from C to method, method.getParameters. Again, we get the list of parameters, and we can print the name and the type of the parameter for each of the declared methods that we have. And again, if I run this code, we'll again find the 3 methods. So drive had 2 methods. One was a char and one was an int. And select drive with a single parameter, and that's just a char. So similarly to methods and constructors, we can get the fields of a type as well. So I can say fields equals class.getFields. And again, we have getFields and we have getDeclaredFields. So in this case, we'll use getDeclaredFields. And again, from here, if we put a loop in, so for field in fields, so here we can do a printout of the name of the field, and we can also get the type of the field as well. So we can say field.getType. And again, if we separate these two, so we do %s, and in fact, let's put the second one in brackets to show the type, and add a new line here, and then run this code. We print the fields from the class. We have a field called speed, that's an int, a field called drive type, that's a char. If I go and look inside my car class, sure enough, we have int and char inside here. So what about arrays? Here in the car class, I've had it a people field, which is an array of string. If I go back into main.java, we can grab a reference to that field. So I can say class.getField. I can say field equals class.getDeclaredField and pass it the name of the field, which is people. Once I have that, I can get the type of the class. So I can say type t equals field.getType, and I can then print out the type of the field. So we can say t.getTypeName to print out the type of this field. If I run this code, this prints out as java.lang.stringArray. So we know that the field is a string array. So of course, we don't want to look at the string representation of the type to discover whether this thing is an array. GetType actually returns something of type class. So as well as printing out the name of the type using t.getType, we could also print out another property of this thing called isArray. And from this we can see whether or not we have an array. So now we get java.lang.stringArray, and we also get true. So isArray for this particular field tells us that we have an array value. And again, a little later, we'll see how we can set the value of the array.